going to go to the next section. All right, I want to look at scatter plots, correlation, and regression briefly because we covered this in a later chapter. We looked at frequency distribution tables, histograms, and we looked at graphs that are good and useful, such as dot plots, stem plots, time series graphs, bar graphs, Pareto chart, pie chart, polygons, ogive, and then we looked at some pictographs that can deceive the reader. So we want to be careful of that. All right, key concept. Could somebody read this one for us, please?
Yes. Analysis of paired sample data, correlation, and the role of a graph called a scatterplot. Introduction to the use of the linear correlation coefficient, linear regression, which involves the equation and graph of the straight line that best fits the sample paired data.
Thank you so much. So we are looking at scatter plots, correlation, and regression. Could somebody read the correlation for us?
Correlation association exists between two variables when the values of one variable are somehow associated with the values of the other variable.
Could somebody read this one, please?
Linear correlation exists between two variables when there is a correlation, and the plotted points of paired data result in a pattern that can be approximated by a straight line.
And this last one, could somebody read that, please?
Scatterplot. A scatter plot or scatter diagram is a plot of paired XY quantitative data with a horizontal x-axis and a vertical y-axis. The horizontal axis is used for the first variable x, and the vertical axis is used for the second variable y.
Thank you so much. Again, in later chapters, we discuss this further, but a couple of things. First of all, correlation refers to a relationship and association, no more. It's not about causation. It doesn't show any cause and effect. Now, correlation doesn't have to be linear, but we are mostly interested in linear. There may be other correlation. For example, a quadratic relationship between x and y. And then scatter plot is very simple. You plot the pairs. By the way, when you plot the pairs as far as the correlation is concerned, x comma y versus y comma x, the correlation doesn't change. All right, so when we look at this example, look at the first one and look at the second one. The first one is dealing with the circumferences of the waist versus the arms. And the second one, weight and pulse rates. Now, clearly, there seems to be something going on here, some sort of a linear correlation in the first case, part A. But if you look at part B, is all over the map. I can't see a linear correlation. So therefore, we say, yes, there is a correlation, and we say pattern of the plotted points suggests that there is a linear correlation. So in short, the answer is yes, there seems to be a linear correlation between what? The waist circumferences and arm circumferences. Whereas between waist circumferences and the pulse rates, we don't see anything. The pattern doesn't indicate any correlation. The next thing I want to discuss is the correlation. Linear correlation is between -1 and 1. And this is just like the slope. I'm going to remind you, everybody remembers the y equals mx plus b. And
Yes.
when m is positive, the line looks something like this. And when the slope is negative, it looks something like that. And that y equals mx plus b is called slope intercept format of a line, a linear equation in slope intercept format. So R is the linear correlation coefficient. It's between -1 and 1. And if it's close to 1, that there is a correlation, positively correlated. If it's close to -1, negatively correlated. If it's in between, like 0 or close, then there is no relationship. Of course, the first and the second one are very clear. By the way, in part C, there seems to be a quadratic relation. I want you to know that, okay? A non-linear relationship. There's a quadratic relationship. This looks like a parabola. Everybody remembers that. Y equals ax squared plus bx plus c. Okay, just, yeah, you don't have to worry about it, but just to refresh your memory. And the last one, there seems to be nothing there. All right, analyzing the scatter plot. Could somebody read that one for us, please?
Positive linear relationship exists when the points fall approximately in an ascending straight line and both the x and y values increase at the same time.
Thank you. Which simply put means when x goes up, y goes up. Could somebody read this one for us, please?
A negative linear relationship exists when the points fall approximately in a descending straight line from left to right.
Thanks. That means when x goes up, y goes down. And a nonlinear relationship exists when the points fall in a curved line. An example of that is part C. And there could be a case when no relationship exists. Sometimes it happens, in which case, when there is no specific pattern which can be described, as it is the case for the last one. All right, we want to see if there is a relationship between the number of wet bike accidents and the number of wet bike fatalities based on the following data. And so plotting the pairs shouldn't be a big deal. We can plot those pairs. This is X and Y. This is another X and Y. This is another X and Y. And when we plot those, there seems to be a positive linear correlation according to the scatter plot. The pairs and seeing the scatter plot and a relationship. Again, this will be discussed with more details in later chapters. So now we are going to look at the following pairs. As you see, the pairs are given, and that simple scatter plot is given. And the scatter plot doesn't seem to show if there is a linear correlation. Definitely, it's not clear. Now, what I want to discuss, which is coming up, and we will look at it with more details, is the following. Here's the p-value, and here's the idea behind the p-value. Again, this becomes very clear when we discuss it in later chapters. P-value, if there really is no linear correlation between two variables, the p-value is the probability of getting paired sample data with a linear correlation coefficient R that is at least as extreme as the one obtained from the paired sample data. Now, if you look at the information on the right side that has been given to us by technology, in this case, StatDis, if you run the data, it gives you one of the values that it gives you is the p-value. And normally, what it really means, you compare it to the specific choice of alpha. Again, what is alpha? Probability of making type 1 error. We're going to discuss that in later chapters. It's put here. I want you to at least have an idea how that works. If the p-value is large, then you, in the test of hypothesis, we have a null and alternative hypothesis. And in the case of a null hypothesis, there is no correlation, H0. Again, we are way ahead of ourselves, but it's coming up in this section. I wanted to mention that. And when p-value is calculated, you compare it to the choice of alpha. So this is compared to the choice of alpha. If it's larger than that, you don't reject H0, which means there is no correlation. And if it's smaller than that, you reject the null hypothesis. That means there is a correlation. You don't have to worry about that as far as the exam is concerned. But I want you to see that here's the explanation. The p-value of 0.294 is high. It shows that there is a high chance of getting a linear correlation. In this case, the linear correlation is this number from the technology, 0.591. By chance, when there is no linear correlation between the two. Because the likelihood of getting R equals 0.591 or more extreme values is so high, 29.4% chance, we conclude there is not sufficient evidence to conclude there is a linear correlation between shoe print lengths and heights. Only a small p-value such as 0.05 or less suggests that the sample results are not likely to occur by chance when there is no linear correlation. So a small p-value supports a conclusion that there is a linear correlation between the two variables. What do we mean by that? Let me just see if I can explain this in a manner that it at least makes some sort of a sense here. You compare the p-value to alpha. If it's larger than alpha, by the way, in many cases we choose alpha to be 0.05. Then what you do in the test of hypothesis coming up, you do not reject the null hypothesis. And in this case, rho becomes 0 in essence, and there is no correlation. If the p-value is less than alpha, and remember, alpha, by the way, doesn't have to be 0.05. Most of the time, we choose it to be 0.05. And if it's less than that, then you reject H0, which says there is no correlation. So again, in the test of hypothesis, we write H0, rho is 0, and H1 rho is not 0. We are way ahead of ourselves. This is coming up in later chapters. I don't want anybody to worry about that. All right, so correlation and regression will be discussed in later chapters. So if we look at this exam, all I want you to see is really the following. What's happening here, the p-value is very small. That's what I want you to see. And therefore, there's a correlation. The scatter plot shows a distinct pattern. The value of the linear correlation happened to be 0.81. This is where it comes from. This is 0.81. Okay, from the technology, we have the value of R, we have the value of P. Now, the scatter plot shows there is a linear correlation, and by the way, the linear correlation is 0.81. Needless to say, the larger the number, the closer to 1, the better the linear correlation, the stronger the linear correlation, and the same thing closer to -1, okay? And so p-value happened to be very small, so we have sufficient evidence to support the claim that there is a linear correlation. That's how we do the writing when we do the test of hypothesis. I just want you to see the concept here. And what is a regression? We given a collection of paired sample data, the regression line or line of best fit or least square line is the straight line that best fits the scatter plot of the data. In other words, is there a way to calculate that line, assuming the line in red, when you go back to the plot, is the line of interest? Yes, the process is called the regression, and in fact, it is given again with the technology. Now, there is a process, we go over that, and you'll see it can be done by hand. Needless to say, it takes forever, but it can be done by hand. So if you look at that one, again, we are just reading from the technology. The general form of the regression equation has a y-intercept of b sub 0, which is 80.93. I didn't write the rest of them, 041. And the slope or b sub 1 is 3.2185. It continues indefinitely. I did round it to 2 decimal places. And so the equation that is used is as follows. We use y hat, really not y. This is the formula. Y hat as b sub 0 plus b1x, where b sub 0 and b sub 1 are given. You put it in 80.93 plus 3.22x. What does that mean? That means that if we do the interpretation of this line, the height is 80.93, let's say, or even 80.9, 80.93 or 80.9, and then 3.22x. What was x? The shoe print length. So the length of the shoe print times 3.22 must be added to 80.93, and roughly that gives us the height of the person.